வாழ்க வையகம், வாழ்க வளமுடன். Dear friends, in this session, we are discussing about the general introduction, methods of preparation, merits and applications of phytosomes in our pharmacy profession. First and foremost, we have to know the meaning of phytosome. Okay, phytosome, phyto and some. The term phyto, it means plant. Some, it means cell. Okay, so phytosome are little cell-like structure. Okay, this is the advanced drug delivery system. I mean novel drug delivery system (NDDS). It is consisting of biologically active constituents of herbal extracts, surrounds and bound by a liquid. Okay, I mean phytoconstituent surrounded by liquid. Most of the biologically active constituents of phytomedicine are water soluble compounds, and it is coming under flavonoid as well as glycosid category. It may be the examples of secondary metabolite. The components may be in this nature. Okay, because certain reasons, majorly water soluble herbal extract as well as lipophilic outer layer phytosomes that will be possessing better absorption as well as result produce better bioavailability. Okay, so the actions that will be compared with conventional herbal dosage form, okay, that will be quicker. So the bioavailability will be very quick because of its novel drug delivery system category. Okay, then for the preparation of phytosomes, we are following different methods. Okay, first one, solvent evaporation method, then freeze drying method and anti-solvent precipitation method. Okay, so some of the important key points as well as merits or applications we can discuss in this session. First of all, we have to know the applications of this dosage form. As a pharmacist, we are studying lot of formulation in our profession, so we have to know the specific application. Okay, so first, most of the phytosomes are focused in Silibin Marianum, which contains premier liver protection flavonoids. So they have clearly explained about the applications of phytosome with a specific example. Okay, so the name itself we can easily understand. It is the extract prepared from the natural origin that might be coated with the phospholipid. Okay, for example, some of the phytosomes are useful for hepatoprotective property. The example, fruit of milk thistle plant. Okay, it is belonging to Steraceae family. It is consisting of flavonoids known for hepatoprotective activity. Next, silymarin. Okay, silymarin, that also another one important phytoconstituent. It has been shown to have positive effects in treating liver diseases of various kinds, including hepatitis, liver cirrhosis, fatty infiltration of the liver. I mean chemical and alcohol-induced fatty liver and inflammation of the bile duct. In this condition, the type of phytosomes can be applicable. Then another one example of phytosome, grape seed. Okay, phytosomes of grape seed. Okay, so the major applications, grape seed phytosomes is composed of oligomeric polyphenols of varying molecular size complexed with phospholipids. Okay, that is the combination. The main properties of procyanidin flavonoid of grape seed are an increase in total antioxidant capacity and stimulation of physiological defenses of plasma. So majorly, if the active ingredient will be available in the form of antioxidant, and they should be used for the treatment of several diseases, and also they will be considered as free radical scavengers. Okay, then it has some other pharmacological properties based on the nature of the plant. Okay, so this is the structure of phytosome. The phytosome will be looking this like only. So they have clearly mentioned about the structures, phospholipid, then curcuminoid phospholipid complex. So curcuminoid, it is obtained from the curcuma longa belonging to Zingiberaceae family. So phytosomes of turmeric. Okay. Next, we can discuss about the physical properties of the same phytosome. Properties wise, generally, if you are studying about the phytosome means they are complex between natural product and natural phospholipid. As we know earlier in the definition part, the phytosome complex is obtained by reaction of suitable amount of phospholipid and the substrate in appropriate solvent such as glycerol. Then majorly, phospholipid substrate interaction is due to formation of hydrogen bonds between polar head of phospholipid and polar functionalities of substrate. When treated with water, they assume a mesial shape, forming structures which resembles liposomes. Okay, so there will be some difference in between phytosomes as well as liposomes. We can discuss about the difference in diagrammatic representation also. Okay. Now, phytosome, how they are prepared? Phytosomes are prepared by reacting 3 2 moles or preferably 1 mole of phosphatidylcholine with 1 mole of active phytoconstituents, mostly the flavonoids and the terpenoids in an aprotic solvent such as dioxane or acetone, from which complex can be isolated by precipitation with non-solvents such as aliphatic hydrocarbon or by liquefaction or by spray drying. Okay, so as we are studying in this topic, first and foremost, the phytoconstituents. Okay, the phytoconstituents are majorly involving. So without the phytoconstituent as well as phospholipid coating, we can't able to prepare. So this will be first isolated. Okay. Next, in the phytophospholipid complex formation, the ratio between these two components is in the range of 0.5 to 2 moles. The most preferable ratio of phospholipid to phytoconstituent is 1 is to 1. The phospholipid as well as the phytoconstituent should be formulated in phytosome as 1 is to 1 ratio. Next, spectroscopic techniques reveals that the molecules of the phytoconstituents are bonded to phospholipid moiety by means of a chemical bond. So there may be some evaluation tests for phytosomes like scanning electron microscopy, then X-ray diffraction technique, etc. Okay. So this is the difference between phytosome and liposome. Phytosomes and liposomes will be structurally differed in this manner. So in case of liposome, water soluble free drug and phosphatidylcholine, and in case of phytosome, phosphatidylcholine drug complex. So this is the differentiation diagrammatic representation between phytosome as well as liposome. And phytosomes are having lot of advantages. Okay, it enhances the absorption of lipid insoluble polar phytoconstituents through oral as well as topical route, showing better bioavailability. The major application is better bioavailability, significantly greater therapeutic benefits, okay, compared to other conventional dosage forms. Next, as the absorption of active constituents is improved, its dose requirement is also reduced. Okay, if absorption rate will be increased, we can minimize the dose of the particular formulation. Next, phosphatidylcholine used in preparation of phytosomes, besides acting as a carrier, also acts as a hepatoprotective, hence giving the synergistic effect when hepatoprotective substances are employed. So the nature of plant use the phytoconstituent, the phytosome application also will be very here. The best example is hepatoprotective phytosome. Next, chemical bonds are formed between phosphatidylcholine molecule and phytoconstituents. So the phytosome show better stability profile. It has better stability profile, and also nutritional benefits of phospholipids will be there. Shortly, if you are saying about the advantages of phytosome means better bioavailability, next better absorption rate, dose reduction, next hepatoprotective activity, next show better stability profile, next nutritional benefits. Okay, so these are the basic information about phytosomes, its method of preparation, applications, and merits. Thank you very much, dear friends. We can discuss the further topics in upcoming session. வாழ்க வையகம், வாழ்க வளமுடன். நன்றி.